Edap saya.
Okay, the time now is 10 past 2. So we have 60 students, 59 students. Okay, can you see the slide?
Yes, sir.
Yeah.
Boleh.
Thank you, Danny. So I saw only one person have taken the quiz for data science program, and 2% have taken the quiz for quiz number 1. So the due date will be on the 23rd. Okay, and for this lecture, there'll be another quiz number 2, which is due on the 30th of November. So I advise don't wait until last minute to take the quiz, yeah. So I will always post up a reminder in the group. Okay, do you have any question before we start? No? Okay, for this lecture, we will look into another alternative. In the previous lecture, we are looking at a single index or a single term. If you recall back what we have studied last week, we are focusing more on a single item or a single word or a single symbol. And then we try to find the weightage for individual item. But in most cases, if you look at the lecture in the previous session, we look at the term-term correlation. Some of the terms, they always come together like software engineering, computer science, information technology. So all these terms are occur at the same time due to the concept that they're trying to pose. Okay, so when we say there is another alternative, set base, so we are looking at more than a single term. So we call it term set. Okay, set of terms. Term here refer to index or keyword or symbol. Okay, so we introduce a set-based model. Set-based means we have more than a single term. Okay, more than a single term. So we are considering 2 or 3 terms at the same time. Okay, so for the set-based model, this is more recent approach compared to the single term. So in which they combine the set theory, because we are looking at the set here, and also at the same time vectorial ranking. We want to rank the document based on a set of terms that we have, meaning that we will consider more than a single term when we perform the ranking. So the fundamental idea is we want to use the mutual dependency, because sometimes we search for computer science or information technology or software engineering. So we want to have um, a mechanism on how we can capture the weightage for these two more than a single term. Okay? So we are saying that we want to capture these two terms that always come together. We call it term dependency, okay? Or term dependence. So before we proceed, it's better to define what we call term set or set of terms. So term set is a concept used in place of the index term. So remember last time in the previous lecture we used index term. So this is referring to a single item only or a single term or a single symbol. Okay. So when we say term set, so we may have more than one keyword at the same time. So in this um, expression, we have n number of term. Okay, so we have n number of term. So we say that if all index term in this set of term occur in document DJ, then we say that the term set occur in the document. So meaning that if you have all this keyword A, B up to N exists in a document, then we are saying that this set term exists in the document. Okay. So, but when we think about the combination of the term that we have, it depends on the number of unique word that we have in our vocabulary. So if we have T number of vocabulary, that means we have a combination of 2 to the power of T. So this is quite a big number lah. So for example, if we have A, B, and C in our list of vocabulary, so the size of this is 3. So that means the term set that we have will be to the power of 3, 8. So we have 8 possible number of term set. Okay. Let me show you the example. So this is our vocabulary. So we could have this number of term set. Okay, so this is empty set. And then we start with key 1, key 2, key 3, and then key 1 and 2, key 1 and 3, and key 2 and 3, and so on. Okay, so the number of possible term set will be 8, including empty set. Okay, so just imagine that if you have 10,000 unique number of word that you have, so you will have a total of 2 to the power of 10,000 number of size of term set that you have. So very large number. Okay. Okay. So again, if we have T number of unique term that we have in a collection, that means we have this number of term set. Okay. So this one is referring to T here. Okay. Okay, let's use the sample that we have before. So we have document 1, document 2, document 3, and 4. Okay. And to make it easier, we change them to a symbol. So keyword A referring to 2, and we just simplify the document. Okay. So over here we have from A to N unique term that we have. Okay? So how many we have? 3, 3, 3, 14. Okay. So okay, let's suppose we want to do query this to do be it. So when we change to a symbol, we have this A, B, D, N. Okay. For this query, okay, we are referring to this query. Yeah? So the vocabulary set is as follow. So since we have 4 symbol here, so we have how many number of term that we could have, the maximum number of set term. So can you type, if we have 4 symbol, okay, how many term set that we have? You can type your answer. We have 4 symbol in our query. Okay. So how many term set that we could have? 2 to the power of 4 kan? So 16. Okay. So we have 16. Okay. So but the one that we have here, we only have 11. We only have 11. How many of these? 3, 3, 4. This is 10 kan? Plus the empty set lah. So we have 11. Yang the rest two we cannot find. Contohnya macam ni. Basically we start by a single term A, B, D, N. Okay? And then we combine A, N and so on. But A, N, no, we combine A, B first, then we get this. And then we combine A, D, we get this. And then we combine A and N. Okay, but we did not list A and here because in our list, in our document here, we do not have any document that correspond to A and N. Okay, so that's why in here we cannot find any AN. Okay, and next one we combine B and D and then B and N. And then we have that. Then after that, we will combine these two, then we get this. Then we combine these two, we get this. We cannot combine this and this. Because what we want to do is we're starting from single, second, and basically this we combine to get the 3 term set, and we cannot combine A, D, and B, N because we will have 4 term set. Okay, so we will start from single, double, triple, and from here, basically we are, if we want to combine, we get A, B, D, and N kan? But this one does not exist in your document, in any of the document here. Okay, so that's why at the end we only have this. Okay, so that's how we create the list of term set that you have. Okay. So once you get that, this one, Once you get all this, then for term set A, we are looking at which document that consists this symbol A. So we just go back to here. So document 1 and document 2. Okay. For the B, we have 1, 2, and 3. 1, 3, 4. Yeah, 1, 3, 4. And for D, we have all 4 documents. Okay. So that the same thing goes to the rest. Okay. So are you okay? Can you understand this? How do we get this? How do we get this? So this one referring to all the document that consists this term set. Okay, so for example, like BD, the BD here exists in 3 documents: document 1, 3, 4. Okay, for this one, term set ABD only exists in document 1. So when we're checking, we need to check all the symbol must exist in the document. Then we can say that that term set exists in that document. So this is how we capture the term-term correlation or term dependency. Okay? Both symbol must exist in that document. Then we consider that symbol exists in document 1 and 2. Okay. So if you're okay, can you type number 3? Okay. So now we are looking at this. So based on the sequence that we have, we say this is one term set, and this is what we call two term set. Okay, two term, dua term, and this is three lah. So in the next slide, it says that at query processing time, only term set generated by the query need to be considered. So this is very important because in the exam, you have to know where you want to start. Okay, so always in the exam, if I ask you about term set, you only look at the query here. So you only ask yourself how many different symbol that we have in this query. So in this case, we have 4. Okay, so we will have 2 to the power of 4 different number of term set that we have. This is the size of the term set that we have. Okay, so that's what it meant here. At query processing time, only term set generated by query. So we are looking at the query here, how many symbol we have, 4. So based on this generation, we only have 11 term set out of 16. Okay. So a term set composed of n terms. So that's why I said when we call one term set, meaning we have single symbol. Two term set means we have two symbol and so on. And let ni be the number of document in which this term set occur. So this is referring to how many number of document that contain this term set. Okay. So an n term set is said to be frequent if the number of document that consist the term set is greater than a given threshold, meaning that, okay, if I say the threshold is 3, okay, so if this term set exists in 3 or more document, we're saying that the term set is frequent. Okay, but if I change this one to 5, that means this term set is frequent only if it exists in 5 or more document. Okay, so this implies that an n term set is frequent if and only if all of its n minus 1 term set are also frequent. So that means if this is a subset of your term set here. If this is frequent, that means the subset is also frequent. Okay. So why do we need to define this frequent term set? Because sometimes we focus on set of term that occur at certain level or certain frequency only. So we want to remove the other term set that is not frequent. So this is used to reduce the number of term set to be considered for ranking. Okay. So for example, we are setting the threshold on frequency on term set be 2. So that means all the term set that occur at least 2 or twice in any of the document, then we call them frequent. So for example, okay, we have this query. So we start with a one term set first. Huh? So by right, you should have Sn here. Okay, but we only have that one in document 4. Okay, so since the threshold is 2, so we only take the one which is 2 or more. That means A, B, D exists in 2 or more documents. But we don't consider this because it only exists once here. Okay, so from a single term set, then we combine this with this, and then this with this, and then this with this. Okay, so A, B, suppose we have A, B, and so which document that I have for A, B? So we have D1 and then none. Okay, so that's why in this list we did not list this one because only one document consists A, B. Okay, so if we continue with AD, so we have two documents, document 1 and 2, and then we continue with BD, then we have 1, 3, and 4. Okay, so if the number of document is less than the threshold, then we do not count in the term set. Okay, we're supposed to combine this, so this combined with this, so we have A, B, D. Yeah? Okay, so A, B, D, we have one only. D1. Okay, so we stop there. We cannot continue anymore. So if in the exam they say list all the frequent term set, then your all frequent term set will be 5 only. Okay. Empty set have to list card? Tidak, sir. Empty set we ignore. Okay. But because in the set theory, empty set is also considered as one of the set, kan? So, but in our course, we don't include the empty set. Okay. If you're okay, can you type number 7? Okay. So, like I mentioned just now, we have 5 frequent term set. Okay. Inverted list for frequent n term set can be computed by starting with the inverted list of frequent one term set. So meaning that we always start from 1 and then we continue 2 and then 3. If no more frequent term set, then we stop. Okay. Okay, now we have to, because just now we just define what is term set and also we define what is frequent term set. Okay, now what we want to do is how do we perform the ranking given a query and we want to rank the document based on the set term. Okay, so if we recall back in the previous lecture, we only compute the weightage for a single term. Okay, but for this one, we are looking at the weightage of the term set or set of terms. Okay, so for that reason, given a query, we are looking at all the possible term set that we have. So given this query, okay, so given this query and given this threshold, our finding that we have 5 term set. So if we go back to this definition, so if we use the same query tadi tu, ABDN, so we have how many term set here? Can you guess? Can you type? If my Q is A, B, D, N, and my threshold is 2, what is the number of term set we have here? If the threshold is 2, given the document that we have. Okay. So if our query is A, B, D, N, and the threshold is 2, based on the previous example, this is your query, this is your threshold, this is your document that we have. We're starting from a single term, then we generate two term, and then we stop. So how many terms that we have? 5. Good one, Chow Kok Pei. So in this scenario, if query is ABDN, if the threshold is 2, then we have 1, 2, 3, 4, 5 frequent term set. Okay. Okay, so this is the definition that we have. So this one referring to the number of document that in which term set SI occur. This is the total number of all documents. This is the frequency of the term set exists in the document. Okay. So remember that when we perform a ranking, we always want to compare between the query and also the document. So we want to compare this. But for each pair of term set and document, we compute the weightage by looking at the frequency of the term set and also the number of document that exists, no, the number of document that consists this term set. Okay. So we also compute the weightage for all the term set or the queue. Okay. So the formula is almost the same with the single term, but this one is for term set. Okay. So always look at the query first. So for query A, B, D, N, and this is document one. Document one is here lah. I just make it long here. Okay. So if we look at the formula here, this one are referring to the frequency of term set Si. Okay. So we are looking at this one. Okay. So we have 4 because we have 4A in my document. Okay. And this one referring to number of document. We have 4 of them here. And 2 is referring to how many document that consists A. So we have 1 and 2. Then we get this value. So remember that this is log base 2. This is also log base 2. Okay. So similar to B, for term set B, the weightage for B in document 1. Okay, so this one we call it the weightage of B in document 1. So for B, how many we have? 2. So we have 2 here. Okay. And this one referring to how many document consists B. So we have 1, 2, and 3. So that's how we get this. Okay. Similar to D, the weightage of D in document 1 will be, so how many times D exists? 1 and 2. So we have 2. Okay, but we have 4 documents that consists of symbol D. 1, 2, 3, 4 lah. Okay. 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 Coba tengok yang 2. So for term set AB, this is how we find the weightage of AB in document 1. Okay. So AB how many times? 1. Tidak boleh double lah. 2. So once you have counted them in one term set, we cannot use back again. So that's why we only have 2. So we only have 2 of them here. Okay. So how many documents that consist of AB? So we have 1, only 1. So that's why we have 1 here. Okay. Okay, we try last one, this one lah. ABD. the weightage of ABD in document 1 will be, so ABD, um, ABD1 and then ABD2. Okay, so the order doesn't count because we remember that this is set of terms. Okay, so if you have DAB, boleh juga dia consider as ABD. Okay, so we have 2 times exist in that document, and then ABD only exists in document 1. Then we get this number. So these are the weightage of all the term set in document 1. Okay, some of them is 0. Contohnya SN ni. So SN, this formula become 1 plus log to the power of 0. So this one is, what is that value? So this is become 0 lah. What is this value? Anyone can try? Okay. So this one is undefined lah. So when undefined means 0 lah. Okay, and similar to BN. BN in document 1, there is no BN here, so 0. DN also, there is no DN here. Okay. So all this computation show you how to find the weightage of the term set in document 1. So in the exam, you may have to do all this calculation. So must be very careful lah. Okay, so any question? So remember that this one is only computing all the term set with respect to the document 1. Okay. In order for us to perform the ranking, we also have to compute the weightage of all these term set with respect to the query. Okay. Because when we want to perform the ranking, remember that just now we computed the weightage of all the term set 1 in document J. We notice that we also have to compute all the weightage of the term set 1 in Q, in the Q. So this is the same formula that we have in the previous one, in which we get the dot product of the document and the query, and then we take the we multiply the magnitude of vector document J and also the query. Okay. So it says that for term set that are not in the query, the weightage will be 0. Okay. Remember last time we also looking at the length of the document. So this is the um, formula that we have, because in document 1 we have 4 symbol here: A, B, C, D. Okay. So this one will compute the length of the document. Okay, so we take the square root of the term set A in document 1, term set B in document 1, term set C in document 1, and so on. Okay, so how do we get this number? That number is, we are taking this one, A, B, D, N. So we are taking all these 4. We take the square plus this, square of this plus square of that, and so on. But in this example, no, we are not taking that. We're not taking this. We are taking this one, because this is the document, not the query. This is the document. So basically, we're taking A, B, C. We need to compute what is C again. Okay. So the C is this one here. Okay, how do we compute the C? So based on the formula, 1 plus log 2. Okay, see how many times exists, 1 and 2. So 2. Okay, and then see how many times the document have, 1, only 1. So times log 1 plus 4, 1. Okay, so that is our, so this is the weightage of C in document 1. Then this one should give you this one. So this is basically the length of the document. We we use this one to normalize the weightage later on. Okay, remember that last week I mentioned that some documents are too long, some documents are too short. So to normalize this one, we have to divide them by the length of the document. Okay, so this is the weightage of all the term set for document 1. Now we want to find all the weightage of all this term set in the query. Okay, so we only consider the non-zero, so we don't do this one to save our time. Okay, okay. So this is very straightforward, because for A exists one time only here, and then this one we follow exactly what we have here, meaning that we referring to 4 documents and only 2 documents consist the symbol A. Okay, so this one is all one, because B exists one time, D exists one time, and then AB exists one time, AD exists one time, BD exists one time, ABD exists one time. Okay, so this one just follow this one. So this is all the weightage of the term set with respect to the query. Okay, so now we have a vector of weightage for document 1. We also have, okay, so this is D1, vector. This is all the vector of query. So we can use this formula. Okay, so we can use this formula to find what is the how similar is the query with respect to D1. Okay, so very straightforward, because if you look at the formula here, so basically we take all the term set in document J and we multiply them with the weightage of the same term set in Q. And then we divide them by the length of the document and times the query, the length of the query. Okay, so we know already what are the weightage for all your term set in this slide. And basically we are just multiply the weightage of the same symbol but from document 1 and Q or the query. Okay, so we should have 7 here, 7 component. Okay, because we have 7. And we divide by D1. We're supposed to times Q, but since the Q is always constant, so we can ignore this one. Because in order for us to perform the ranking, we also have to do similarity for document 2. Okay, and then we have to do the similarity for document 3 and Q, and similarity of document 4 and Q. Okay, so notice that if you're finding the similarity between document 2 and Q, that means this one will become D2. And then if 3, D3. But this one is always consistent Q, right? So for that reason, we can eliminate this one just to simplify our calculation. Okay, so this number is just a number saying that how close is the document 1 to Q. The higher the number, the closer they are. Okay, so notice that this is only the similarity between document 1 and Q. Okay, so if you want to do 2, D2 and the Q, then you need to start all over again here. But instead, this one you replace with document 2. Okay. Okay. Any question? Okay. Okay. Now, the last subsection will talking about, if you look at this one, if you look at the weightage of AB, this AB coming from here. AB are the subset of AB here. So they say that why not we only take the biggest one, because this is a subset of this. Okay? So they call it closed term set. This is closed term set. The concept of frequent term set allows simplify the ranking computation. Just now we introduced frequent term set, kan? So that means we only consider term set which are frequent, and this allow us to reduce the number of term set that will be considered. Okay. Now we introduce the notion of closure. So the definition here is that the closure of term set Si is the set of all frequent term set that co-occur in the term set in the same set of document. So which means that if A is and B is term set, frequent term set, and also AB is also frequent term set, so we do not have to consider this because this is a closed term set for this. Okay. So these are the definition. Given the closure of this term set, which is this, the largest term set in it is called a closed term set. So this is the closed term set. Okay. Okay, so we formalize as follow. Let Di be a subset of C, be the subset of all the document in which the term set Si occur and is frequent. And then let S, this is term set, be a set composed of frequent term set that occur in all the document Di. So we have the document that consists of the term set, and also we have the term set which is frequent. Okay. So then the closed term set, which is this symbol, satisfy the following property, which says that there is not exists a term set that belong to a term set that exists in this document such that this closed term set is a subset of this. So that means this closed term set cannot be a subset of another term set, meaning that a closed term set must be always the biggest one. Okay, must be the biggest one. For example, this tree is smaller than this one. So we take this one as your closed term set. We cannot take GH because your closed term set must not be a subset of any of the term set that we have. Okay, so that's why we take the biggest one. Okay, so if the frequency is 3, we get BD, and then frequency of 2, AD, we get AD, and so on. Okay. Okay. How do we determine the closed term set? Okay. So we use the same example here, Q, and also D1. Okay. So this one we get from the previous calculation. Okay. So what we want to do is we want to do the pairing, like D1 and D1. What else? Okay. So we combine these two. So we combine that two. These two is here. Okay. Because the A and AD cover the same document here, but this one is bigger than A. So we take this one as your closed term set. Okay. Okay, which one? Okay, we have this also 3. So we will take this one, B and BD, and B and BD is this one. Then the closed term set will be BD. Okay. This one, no pasangan. Okay. Okay, D4, and BN. Okay. But this one we do not consider because they are not in the frequent term set. Okay. What else? AB, and this one is here. Okay. Um, I'm sorry, just now we did not consider this and this because we are referring to D1 only. Okay, so we only consider D1. This, this, and this. This one, no. So the one that we don't have document one, we will not consider. Okay. So let me erase some of this, make you more confused. Let me start again. So we always find the pairing. So this one pairing with this. Okay. This one pairing with this. We, and then document one and document one. So this one will be combined. So we have AB and ABD. Okay. Yeah. Okay. So that's how you get this one. So when you simplify, the final term set will be only this because some of them are duplication like this, and BD also, and so on. Okay. So the final term set based on the closed term set will be this. So when we compute the ranking now, because in the previous one, we did not consider any of the closed term set, so we have 7 of them. We have to use 7 of them. So when we eliminate some of the non-closed term, so we now only have 4, so we only multiply 4 of them. Okay, and this is the length of the document, and we get this value. It does not mean that this is lower than this one because this one we use 7 weightage. This one we use only 4. Only 4 this one. Okay. So this one we reduce the number of weightage to be considered. Okay. Okay, let's because this one we are not considering any frequent term set. Now let's introduce this one again, the threshold 2. So the threshold 2 meaning that we will not consider term set which occur only one time. So we will not consider this, will not consider this, and this, and this, and okay. So we only have this with this. We get that one, and then this 3 and 3. We get this one. And then AD is here already. BD is here. So basically we don't need this one. Oh, final term set D. Where is D here? here. Oh, we need this one because exists 4 times. So this is okay. Okay, because D exists 4 times. So when we simplify all this, we get only 3. And we only compute the 3 of them. So notice that from here, we use 7 of them. So this is without the closed term set and without the frequent term set. And then if we simplify them, then we get 4. Then we less computation. And then next one again, we introduce the threshold 2. So we only consider 2 and above number of document here. Then we have this. So all 3 are the same, but the last one will apply different number of weightage, least number of weightage. Okay, so please ignore this exercise. The new exercise ada dalam ni. I will post them. Okay. I think this one ada solution dia lah. So in the assignment, some of them ada solution for the previous semester. So you can study and you can do the assignment lah. So tonight I will release assignment number 1 and 2 lah. And I think it's due 2 weeks, 3 weeks lah. But before your midterm. Okay. Okay. Daphne, no question, huh? So the rest, okay kah? So later on today, I will post the assignment. So try to do it. Try to understand the question. Okay. Abdul Kawi, are you sure? Line clear? Okay. So for the rest of the student, I hope you don't shy to ask question. So you can also ask question in the WhatsApp. Okay, maybe your friend also have the same question. So we will meet again next week. But before that, your midterm, your semester break 28 bahkan. When is your semester break? 28 or 29? This week kan? 29 of November kah? Your semester break. Okay, so you coming back on the 6th kan? So can we have the midterm on the 7th kah? Okay, so 7 we will have the midterm. So try to finish the assignment by the 28th lah. Okay, and I will post the solution for your assignment number 1 and 2 after 28. So basically you have 2 weeks lah to complete your assignment. Okay. Okay, so any other question? No? No. Quiz line, the assignment also line. So tonight I will post the assignment 1 and 2. And it's due 2 weeks from today lah. Okay. Ko Wei Kwan. Okay. Okay. So if nothing else, see you next week.
Doctor, I couldn't scan my attendance just now. Can I
No,
give my
okay.
matrix number?
Yeah, you can type your matric number.
Okay, thank you, Doctor.
Siapa lagi yang belum dapat nih scan? You type you punya. Next week midterm tidak. Our midterm will be on the 7th of December. Okay? Yeah, 7th of December.
Thank you, Doctor.
Welcome.